So this one is the one that's going on 67. So I meant to ask you a question before I gave this to you, so that you weren't trying to read the answer off of here. But so who wants to tell me why we do synthetic division? Anybody? Do you even know why you do it? To find a factor. What do you have? Do you have to know something before you try to find the factor? Like you're trying to check to see if something is a factor, right? See if it's a factor. Okay. There's other ways you could use it as well, right? And so it is important. You did do it in Algebra 2, so this is a review, but I want to make sure that you understand what it really is, what you use it for, and that there are actually theorems that go with it, okay? There's something called the remainder theorem and something called the factor theorem, okay? So the remainder theorem says, if a polynomial f of x is divided by x minus c, right? So then whatever the remainder is, right? If it's a factor, what is the remainder? 0, right? Which means that if I plug in x, then whatever that is, my y value should be 0, right? Okay, so then the remainder r is f of c equals r. If r is 0, then that means that y is 0, which would mean then that it's a factor, right? But that also allows you to evaluate a function and not just use it to find a factor. So this allows you to evaluate f of x for x equals c by dividing f of x by x minus c, whatever c might be, using synthetic division. This is when we did, when I was making the key for the summer assignment, and I don't even remember the exact question, but it had to do with quadratics. And I was up here and I was doing the video and I was doing it, and I guess at some point I found x and I needed y. I don't know if I was looking for the vertex or whatever it was, but I was thinking the whole time like I totally know how to do quadratics. And then I looked at the key that Miss Rice had worked out, and all of a sudden I had to pause because I was just winging it, and I thought, what the heck did she do there? Like, why in the world? And then all of a sudden I couldn't even find y. And then when I asked Ms. Archer about it, she was like, you just plug in x to get y. I was like, oh, of course you do. I said, okay, that's what I thought. But then I have this over here, and it was synthetic division. Like, why do I have to do synthetic division? Well, she didn't have to do it. That's just how she chose to do it to evaluate it. And I didn't catch it because I wouldn't have thought to do it that way, you know, to find the vertex or whatever. But you can do that to actually find a value, okay? So this process is called synthetic substitution. So your remainder is important for a couple of different reasons. If it isn't 0, then it still gives you some information that you may or may not need or care about at the point, but it still does give you information. So that's the remainder theorem. Then we have the factor theorem. And the factor theorem says x minus c is a factor of f of x if and only if f of c equals 0, meaning the remainder is 0. Okay. This means you can use synthetic division to check if, and I know this line is probably not long enough, but linear binomials goes there. To check if linear binomials are factors of polynomials. If the remainder is 0, the binomial is a factor. Okay. So linear binomials, 2 terms, has to be linear. That's why we need synthetic division and long division, because you can use long division for any of them, but synthetic division only works if it's a linear binomial. And the coefficient of x has to be 1, so if it's not, you'd have to divide through, and I know you did that in Algebra 2 as well. I saw that ISN yesterday, so you can't lie to me. But right now, I'm just going to give them to you like that. Okay, so there's steps over there. We'll talk through the steps. Some of you may not really need it because you remember how to do it. But we're not only going to divide using synthetic division, but we're also going to explain the meaning of the remainder, because I want to make sure you understand why you're doing it. So it says we write the value of c in the box and the coefficients of the dividend in the first row. When you do this, I am dividing by x plus 5, which means when I do my synthetic division and I put it in this little box right here, what number goes there? -5, because this is x minus a -5, right? And remember, it's supposed to be x minus c. So you have to take out the opposite of what you see there. So -5, and then the coefficients here, And you have to insert a placeholder just like you do in long division. Here I don't need one because it goes 3, 2, 1, 0. I'm good. So my coefficients are 1, 1, negative 17, and 15. And make sure you don't write them too close together because then you'll regret it in the end. So this last one here, I'm going to box off because that's where our remainder goes. Okay. So then we bring down the first coefficient. I just bring down the 1. Negative 5 times 1 gives me a negative 5. That's what I write right there. So then do I add them or subtract them? These two numbers. Do I add or subtract? I add them, right? Which technically is like subtraction because the signs are different. But you're adding. So it's different than long division. I add those two and I get a negative 4. Right? Then I multiply. Negative 5 times negative 4, what does that give me? 20. And I put that here. I add these two and I get 3. Then negative 5 times 3 is a negative 15. When I add those, what do I get? 0. So my remainder is 0, right? Then I need to write out the quotient. Okay, so it says the coefficient of the terms of the quotient are in the bottom row. Since this was a cubed, then this means this is going to start with x squared. So this gives me x squared minus 4x plus 3. That's the quotient. That's what I get when I divide. Then I also need to explain the meaning of the remainder. Since r equals 0, what does that tell you? What does that tell you about x plus 5? It's a factor. So r is 0, then that means that x plus 5 is a factor. And I won't make you write out is a factor of and write out the whole other one. Okay? I could make this worse. I could make you write out a whole other stuff. But I want every single time for you to explain what the meaning of the remainder is so you understand why you're doing it. The more you understand why you're doing what you're doing, the more likely you are to be able to actually apply it when you need it and somebody isn't telling you, hey, use synthetic division, right? But this explains all this stuff, what happens if the remainder is 0, but I put all the words here if you need to go back. But those are both parts of the answer. We good? Yes? Awesome. Let's do a couple more. So, same directions. And let's do this one together. So, what do I put in my little box? 2. Then I have to write down, now am I going to have to put any placeholders in here? Yes. For x to the 4th, it is 1. For x cubed, it is 1. For x squared, I put 0. For x, I put 0. And then I have a negative 1. So whatever the degree is, you should have one more number here. So I have 1, 2, 3, 4, 5 because my degree is 4. So that way you can make sure you have other placeholders. Then I'm going to box off this last one for my remainder. Bring this down. So 2 times 1 is, what? 2. So that gives me 3. 2 times 3 is 6. Gives me 6. 2 times 6 is 12. Gives me 12. 2 times 12 is 24. So my remainder is 23. Okay. So now I need to write my answer, write my quotient. Right. So that was x to the 4th, which means this right here starts with x cubed. So I get x cubed plus 3x squared plus 6x plus 12 plus what? 23 over that right there, x minus 2. So there is my ugly quotient. Then I have to explain the meaning of the remainder. The remainder I got was 23. So what does that tell me? Well, it's not a factor. But what it does tell me, so that's what it tells me it's not, which is right. It is not a factor because f of 2 equals what? What does f of 2 equal? Look back here. Let me ask it this way. What does f of negative 5 equal here? 0. That's the whole evaluating part of it, right? Since f of negative 5 equals 0, that means y is 0 and x is negative 5. That's what makes it a factor. Does that make sense to you? So here what this tells me is that f of 2 equals 23. It gives you a point on the graph even though it's not a factor. Does that make sense to you? That's why I want you writing it every time, because I want you to understand what it is that you're getting. That's the synthetic substitution part of it, where you can evaluate it. So even though I didn't get that, I do still have a point on the graph, even though I don't know what one of my zeros is. Okay, we good? Everybody good? All right, do the next one on your own. Don't just look up here. Make sure you've actually done it. Don't just copy mine down. But it takes a long time after you've done it for me to then write it up here. So I want you to do it. Make sure you've got it done. You can check yourself with me. Ask me if you have any questions. What are we confused about? Okay, because you don't have your placeholders. This is x cubed, right? So this is like saying x cubed plus 0x squared minus 30x plus 0. So remember, whatever the degree is, you have to have one more number up here. So the degree is 3, which means I have to have 4 there. I have to have a placeholder, even because this is like 0 times x to the 0 power. And this is like x to the first. It's got to go all the way down. Does that make sense to you? So you need placeholders for both. Everybody good with that? Got to put those zeros in or you're not going to get the right thing. And then f of negative 5 equals what? 25. It's whatever the remainder is, right? No big, but you need both parts there. Work, all that stuff. If you were to do this with long division, the long division took a lot more work, right? Basically, this collapses it all, and it does make it a whole lot more simpler and a little bit quicker. But again, it doesn't work for every type of division that you're doing. Okay, we all good? Jasmine, you good? Yes. Okay. All right. So let's look at the next one, and let's just go ahead and do this one together. So I'm going to get negative 1, get 1, 7, negative 1, negative 7. Get 1, negative 1, right? This gives me 6. So what do I put here? Negative 6 makes this negative 7, which means here is 7, and this is 0. So this is a cubed. So that means this is going to be my x squared. So x squared plus 6x minus 7. What is your remainder here? 0. Okay? Which means that x plus 1 is a factor. It also means that f of negative 1 equals 0, right? We good? Yes? Okay, awesome. Then go ahead and do the next one on your own too. And then the last two are a little bit different. Okay. We're good with this? Any questions on this one? Did I do it too fast? Or are we good? Okay. All good? All right, let's look at the next one. Now, next one says find the value of k so that the remainder is 0. So it gives you this, but we don't have a number there, we have k. But just like anything else you do, we don't just freak out because there's a variable, right? We do the exact same thing we've been doing, right? So I'm going to take this x plus 2, I'm going to put my negative 2 right here. And then I'm going to write out my coefficients. This coefficient is 1. For x squared, it is 8. For x, it is k. And then this is 4. And in this case, we know what we want the remainder to be. We want the remainder to be 0. So I'm going to go ahead and put that in there. So then we start working it, just like the rest of them. So I bring down my 1. Then I do negative 2 times 1 is negative 2. That gives me 6 here. Negative 2 times 6 is negative 12. So what do I put right here? Okay, well, it's not negative 12k because I'm not multiplying. It would just be k minus 12. or negative 12 plus k is the same either way, but it's adding and subtracting, it's not multiplying. Then I take this negative 2, and I'm going to multiply by this, so this gives me negative 2 times k minus 12, right? Well, in order for this right here to be 0, what does this have to equal? Negative 4, right? I need that to be a negative 4. So that gives me my little equation. I can say negative 2 times k minus 12 has to equal a negative 4. Does that make sense to you? Super duper easy little tiny equation, because I just went through and did it just like I would anything else. Just because there's a variable there doesn't change your steps in your process. You just have to know what you need that to be. And so now that I have that here, do I have to distribute the negative 2 first? No. I can go ahead and divide and just get then k minus 12 equals what? 2. So k equals, I got to add 12 to both sides. And then if you go back here and look at what would happen, well, if this was 14 and a negative 12 gives me a positive 2. Negative 2 times positive 2 gives me a negative 4, and that works out just fine, okay? But you have to be able to set up and solve simple little equations. Yes? Okay. Where's the negative 4? Well, we knew the remainder needed to be 0, and this is 4, so that's how I know this has to be negative 4. The only thing that's going to give me 0 here is the negative 4. Does that make sense? So you have to decide whatever's going to go here. I mean, you could set it up a little bit differently and say that 4, I could do it differently. I could say that what you know then, if I add these two together, I get this, right? So I could set it up differently and say 4 plus a negative 2 times k minus 12 has to equal 0, right? Isn't that what has to happen? And so when I move my 4 over there, that's what makes it a negative 4. It was just a different way of looking at it. But it works both ways. I mean, you can set up a full equation like that, if that makes more sense to you. Whatever works for you is good. Okay, does that help? All right, good. Anything else? No? All right, last one. Katie. Come on, girl. I know this stuff isn't that exciting. I promise I'm going to work on finding a way to make some of this exciting, but there's really nothing exciting about synthetic division. The exciting thing about synthetic division is that it's shorter than long division. That's the best I can do. All right, so determine how many times 1 is a root of this function, find the other roots, and write f of x in factored form. All right, so you did synthetic division. Did you do it where then you kept going, like you did it again, and you did it again? I'm not sure if you do that in algebra 2 or not. But I want to see how many times 1 is a root, which the answer might be 0. But if 1 is a root, when I make my little box here, do I put a negative 1 right here? If 1 is the root? No. Okay, so this is just 1, right? Then I'm going to write this out. I'm not missing any. I don't need any placeholders. So this is going to give me 1, negative 2, negative 3, 8, and negative 4. Yeah, no. Okay, then here's where my remainder goes. All right, so 1, that gives me a 1 here. So that's negative 1, negative 1. Negative 4, negative 1. I'm sorry, 1 times a negative 4 is a negative 4. That gives me a 4. This is 4. This is 0. Okay? So, is 1 a root of this? Yes. Does it say is 1 a root? No, it says how many times, which means now, basically I've factored this out. So now I do it again. I'm going to use my result and then do synthetic division again with the 1. This time my remainder will be right here. Because now I've taken it from a degree of 4 to now this is a degree of 3 that I'm trying to figure out if that one works. So what? Bring down my 1. Then this gives me 1. Right? This gives me 0. So 1 times 0 is 0. Get negative 4. 1 times negative 4 is negative 4. So I get 0. So is 1 a root twice? Is it a double root? Yes. So now I got to do it again to see if maybe it's a triple root. Here's a 1. Do it again. My remainder will end up right there. Bring down my 1. 1 times 1 is 1. That's 1. 1 times 1 is 1. So I get a negative 3. So is the 1 a triple root? No, it is not. So now we got to now I've got to be able to make sense of all this stuff, right? I know that it is a root twice. These two work. This one does not. Since that one does not, this doesn't mean anything to me either. I have a fourth degree. This is 1/2 of the degrees. This right here gives me the other two. Okay? Which means what I have right now is f of x equals x minus 1 times x minus 1, right? Because it's a double root there. And then this right here is going to give me x squared what? What does this give me? X squared plus 0x, then what? Minus 4. Everybody understand where that came from? Yes? Can you factor that more? Yeah, can you factor the x squared minus 4? Yes, you can. So f of x, and what should I really do with this x minus 1? Combine it. So x minus 1 squared. Then x squared minus 4 factors into what? X plus 2, x minus 2. Okay. So there is my function in factored form, and I have to find all the roots. So the roots are what? 1, -2, and 2, right? So -2, 1, and 2. And I want you to get in the habit of putting them in order from least to greatest instead of just a hot mess of points in there. Okay? We good? It'll make more sense to you when you're doing stuff. Any questions?